All set? Yes, great. Okay. How many of you have worked with MongoDB before? Okay. Few of you. How many of you are familiar with other databases that are NoSQL databases, like non-relational? Okay, few of you. Who all don't have any idea of NoSQL databases? Have only used to relational databases? Okay, most of you, I guess. All right. So MongoDB, if you know about it, I am assuming most of you don't know about it. So it's a NoSQL database, and let's go over some questions and see how much you know about MongoDB. So why was MongoDB named MongoDB? This is for the folks who are using MongoDB. Where did the name come from? Any idea? No idea. Okay. It comes from the word humongous database. So that MONGO is plugged from there. So that's how it was named MongoDB. Any idea when MongoDB was founded? Which year of launch, anything? Yeah, that's right. So it was in 2007 that they started a company, the three of them, and then it was launched in 2009. So it was fairly around that time. You're right. So what was the name of the company that founded MongoDB, the former name? No. Okay. It was called Tengen, and then they renamed themselves to MongoDB later in 2013. And what type of NoSQL database is MongoDB? So this is a fairly easy to want to answer. Yeah. Yeah. Exactly. It's a document database. So yes, and last question. What is the latest version of MongoDB? No idea? Okay. The latest version is version 7 and version 8 is to be released in 2024. It's in the preview version right now. All right. Let's jump into the session now. Hope everybody is now warmed up with the questions. Yep. Okay. So MongoDB, as we saw, it comes from the word humongous database, and it's a document database. So instead of storing data like a relational database in rows and columns, data is now stored as a JSON. So how many of you do not know JSON? Okay, all of you seem to know what JSON is. So we have this JSON structure here, and this is how a typical document will look. And the advantages of using JSON over the normal relational data structure is that it's faster, it's intuitive to use, and it is easy to adapt. The thing is that you need not have a fixed schema or a data structure defined in advance. So if you want to have more fields added, you can append it right away in your JSON. So that is the advantage of using JSON structure. So that's what our MongoDB uses. And there is something called as bson. That's what MongoDB uses. So in JSON, we have some problems that they face. So the problems are like you cannot use much data types, date time, binary data are not supported. You have only a fixed length, so searching is difficult, and also metadata storage is difficult. So MongoDB uses something called as binary JSON, which is the exact binary conversion of this JSON, and then it uses for internal representation. So internally, all your data types are supported in bson. So you have additional data type support in bson over here, and it's mostly machine only. So Next, we go to collections. So in a normal database, you will have like a database and then you have tables. So the equivalent in MongoDB is called collections. So a collection of documents, like you have a collection of rows is a table. The same way a collection of documents is called collections. And that's how we refer in MongoDB. So I can show you a typical example. So employee is the database and employee info is like the collection that is holding all the documents. And here you have a document. I can show it in the JSON format. So here you can see this is one document and this is the other document. And you can see that these two documents are similar, but they don't have all the exact same field values. So you have additional field value over here, which is like the last worked on. For example, the employee has left. So the last worked on date is filled. And you have other data types also. So here you can see support for date. You can have array, binary, Boolean, int, object. So a lot of data type support is also available, and that's because of using Bson internally. Any questions so far? All clear, I hope. Next, we go to replication. So any idea what is replication, like what it means? Just the term replication. Yeah, duplicates. So MongoDB by default offers replica sets in its support. So you can have more than one replica of data. You can have up to 50 replicas of your data present. So if you configure your replica set accordingly to how many nodes you want, that many replicas of your data will be present, and all the data will be replicated across all the different nodes. So one of your node is called the primary node, like to which all the write operations happen. And post that, you will have all the other secondary nodes to which the data, whatever changes happen in the primary, they are asynchronously replicated. So asynchronous replication, by this we mean that when a data change or a write happens in the primary, it won't immediately get reflected in the secondary. It will be written to something called as operations log, op log, and based on that, that op log will be read by the secondary and it will update itself. So this is how the replication works within the replica sets. And see something called as heartbeat here. So this heartbeat is like health check, like constantly polling for each other. And if one of them goes down, majorly if the primary goes down, then the secondary needs to take over. So this feature is automatic in MongoDB. And if the primary goes down, an election is held for the new primary. So the next eligible secondary will be elected as the primary. And now this node becomes the new primary and the replication will happen between these two. So this is how the replication happens, and also the election happens when the primary goes down. And there is a concept called as arbiter. So this arbiter is like when you have a scenario where you have one primary and you don't want to have multiple replicas of your data. You just want one more replica so that in case your primary goes down, you want your secondary to come up. So this is the structure. In that case, for the purpose of holding elections, you have a node added called arbiter node. So this node will not hold any data. It will do only voting and act as a dummy in the election process and help your secondary become the new primary. So this is the function of arbiter. Any questions so far? Yeah, sure. It will become a secondary. It will become a secondary, and this will continue to be the primary. Yes. Replication, yes. And reading from secondary. So you can also use your secondary nodes as a read server. So all your writes go to the primary server, And your secondaries, because they can be used for reading, it will increase your read performance. So that is also one of the advantages when you are configuring a replica set. Okay, before we go to the next topic, any other questions so far? Yes, only when the heartbeat goes down and the primary goes down, this election happens for electing the new primary. It should be within 12 seconds. That's like the SLA that they say in the documentation, ideally. Downtime, yeah. So the replication should happen really very fast. So ideally, it's very fast. If there is a lag, then that's the cost that we are paying for higher performance by reading from the nodes. So I don't think so. Yeah. Any other question? So when a write happens and an update happens, the oplog is also automatically updated simultaneously. You're asking for the time period, but I'm not sure how fast or slow that will be. Mhm. It will happen automatically. So once we configure the replica set, it should automatically happen. It will happen automatically. It will be only one oplog. That's my understanding. So it will read from the oplog that the primary writes into and do the replication. That's my understanding from what I have read so far. Any other question? Okay, I take that as a no. Scaling. Now we go to the topic of scaling. Uh, Hope all of you are familiar with this horizontal and vertical scaling. Yeah. Okay. So can any of you tell me what is horizontal scaling? What do we do in horizontal scaling? Okay. And then by adding more servers, how does it improve the performance? Reroute. Okay. Mm. So more instances. So in context of MongoDB, how we handle horizontal scaling is by the concept of sharding. So here you have multiple subsections of your data. So that's what a shard is. So instead of multiple replicas of your data, so that's when you reroute to the different. So the concept which he has told, that is related to when you have like a web service. So you have a load balancer sending you to different instances, and that helps you improve the performance by horizontal scaling. In case of MongoDB in sharding, what we do in horizontal scaling is that you chunk out the data into particular ranges or like particular portions of data. And one portion goes into shard A, the other portion goes into shard B, other goes into shard C. So this is how data is split. And the metadata is also stored in a particular place. And when there is a request coming in, it will know which shard to direct to. And based on that, the data is retrieved. So even if your data grows bigger and bigger, you can increase the number of shards and achieve the same amount of performance that you will get when you had lower amount of data. That is the concept of sharding. Any questions so far? There are two services. We'll talk about that. The metadata is stored in one place, and there's a router service as well. Yeah, we'll go over that. Yes, definitely it will cause performance. So now that's what we are coming to shard key. So if you're querying by the shard key, then you won't have performance issues. You will already know which shard the data is in. But if you're querying across, for example, let's say your shard key, by shard key, I mean what is the value with which your data is split. So if you have chosen something like your for example, you have a customer database or employee database. Let's take employee database. A particular range of employee IDs, first 20, then 20, then 20. So till 60, it is ranged, and then the rest of it goes to the last shard. If this is how you have distributed your data, and then instead of searching by employee ID, you are raising a query where you are trying to find out the employees by their PIN code number, their address, their PIN code. In that case, your query has to go through all the shards and search for that particular PIN code number occurrence and then bring out the data. That time, it will be a costly operation. So your shard key, so whether it is efficient or not, that will depend on the querying pattern. So that's the last point here that is mentioned in while choosing a shard key. So if your query pattern is more likely to be on your PIN code, then that's a better shard key than using the employee ID. So that's how you have to choose the shard key so that it doesn't impact your performance. But if you use something other than shard key where it has to go to all the shards and retrieve the results, you are going to have a slowdown in performance. Hmm. Okay, like what I didn't understand in your question is you are trying to compare like the relational and NoSQL database. So the advantage you're saying is that you need not know your schema upfront. But when you're trying to do a sharding, you need to know the schema upfront. So yeah, you need to understand your query pattern. You need to understand your data structure. That needs to happen. Yes. The schema can be different. But the thing is, this shard key should be there in everything, or else the null shard key will be handled differently. There is a handling for that, but I'm not sure how that's handled in the entire document, which is the shard key or the key with which you are trying to distribute. Well, Yeah, you don't need to know the entire structure. You just need to have one constant key with which you are separating across the shards. So that's what is more important than the entire structure. That one shard key should be there in almost like all of your documents in your collections. So that's the group. So primary key, the ID generation. Okay. Hmm. If I understood your question correctly, you're asking how will, when sharding is done, how will it know what is the newest ID it has to insert for the OID? Mm-hmm. Okay, I'm not sure about this. I have to look it up. I'm not sure. But yeah, the thing is, when you are like sharding concept is not about the like you have a shard key and then you put it in the particular shard. So the ID generation, it should be tracked somewhere else, right? Like when how it's automatically generated. I'm not really sure about that. Any other questions? Okay, I'll take that as a no. So factors to consider while choosing a shard key, the cardinality of the shard key. So this, by cardinality, we mean like how many possible values a particular thing can have. For example, male and female, the cardinality is 2. If you take the continents, the number is 7. So if you choose those things as the shard key, then you are limited by number, by the number of, like if you're choosing continents, then you're limited to only 7 shards. That's all you can have. So you should be choosing something that is more widely like scalable, like the pin code ranges, for example. You can go even granular and increase the number of shards as your data grows. So that is how you should be choosing the shard key, and frequency with which your shard keys occur. So for example, if you have like in your data set, you have people living in Chennai more than people living in, say, Mumbai or Delhi. And then you are trying to segregate by location, Chennai in one shard and Mumbai in one shard. then Chennai is going to be heavily loaded and very big. So that's also not a good idea. So you should choose in such a way that your, like the data will be evenly distributed. So as Sudan asked, like you should know how your data looks. Only then you can do this better. I agree. And whether a potential shard key grows monotonically. So if you have something like a employee ID, for example, it's just going to keep increasing as the number of new employee joins. So it's not going to change in any way. So in that case, if you put the first 20, next 20, next 20, then and then the last 20 till the end number goes into the last shard. Then if your thing employee ID keeps growing, plus one, plus one, plus one, everything goes into the last shard. Same way, if other way around, if everything goes to the smallest number, that's also not ideal. So that should not be chosen as the shard key. And then the query pattern. So you need to have an idea of how your data will look beforehand in order to distribute your load pattern to get the best out of MongoDB in sharding. So next is sharding strategies. So there are three different sharding strategies, like how we can define the shard key and what we can do with it to shard. So in hashed sharding, we take a particular value, like the particular shard key, and then do a hash function on it, and then route it to a particular chunk based on the hash value. So this is hashed sharding. And then there is a ranged sharding. So if there is a particular series of numbers, like series of pin codes or employee ID ranges, so one particular chunk will take from this minimum key to this particular key, and then from this particular key to here, and this particular key to here. So this is how this chunking is done. So that is ranged sharding. And then we have something called as zoned sharding. Here we have a tag for a particular data, and we can say it like for GDPR compliance or things like that. You want to have data inside a particular region, so you can provide tags and say this data should be stored in this particular zone. So that kind of concept is mentioned as zoned sharding, where you have particular tag and you use that tag to segregate it into zones. So zone A and zone B goes into this particular shard. Zone C, zone D goes into this particular shard. That kind of segregation is told as zonal sharding. Yeah. Any questions so far? Yeah. Yes. Yes, resharding can be done. You can change the shard key anytime and it will be rebalanced. There is a kind of a load balancer, rebalancer available in MongoDB internally. And when you change the shard key, it will slowly migrate all the data into different other shards. Slowly, it will happen like while your database is still running, all this data movement will happen. So your database need not be brought down and done. This change can be done and the data will rebalance. Each shard is a replica set on its own. So all the data will be moved internally and you won't realize it. All your when we see about how queries work in a sharded environment, that time you will understand. It won't get disturbed actually. Yeah. Any other questions? Uh, you're asking in terms of if the data is located in a different location, how much lag you will have. So if you're using something like a cloud service, so for example, MongoDB Atlas cloud provider, then in that case, there shouldn't be much lag. You shouldn't face that much. It depends on how it's hosted. Like that's what I think. Mhm. Was that answering your question? Like I didn't really follow. Okay. So now we come to how querying works. So when a query comes in, you have a query router called MongoS. So this will refer to this config server. This config server now has the metadata, and it's also a replica set. It has the metadata to understand which shard has what data and what is the shard key, all of those information, and then it routes it to the right shard. So this is like the metadata store, the config servers, and we have a specific router for this which will refer to the config servers and route our query to the right particular shard. So this is the mechanism that happens when a query comes in. So like, was that clear for you? Like, yeah. So there is a router called MongoS. So when a query comes in, it goes to the MongoS, and the MongoS looks up the config server. This config server has all the metadata that is needed to identify where your data is, which shard it goes into. And then the data is routed, I mean, the query is routed to the right shard. So this is how the process works. If your, yeah, if your data, like the query result that you're expecting, is present in multiple shards, then your config server will say which all shard it will be present. If it is not able to identify, in that case, it will go to all the shards. Or maybe your data is distributed across all the shards as well. In that case, it will go to all the shards and fetch the data. And it's called a scatter gather query. So it will go to all the shards, pick the data, and this Mongoose will do the merging of all this data and give back the result to you. So at that time, your performance will not be at the peak. It will take some time, some more time. And any other questions on this? Okay, I take that as a no. And this is about, yeah, the query pattern, how it works. So broadcast operations happen when, like, you have queries like update many or delete many, things like that, which need to go to all the data. So it has to go to all the shards. And if sometimes your mongoose also does not know where your data is, which you're looking for, maybe it has to search in all the shards to find out the relevant data, and it's not based on your shard key or something. In that case, mongoose will broadcast this particular query to all the shards to find out the relevant results, and then do the joining and give back. So this is how the broadcast operations will work. And if mongoose was able to identify the shard right away, it was a direct read operation, maybe based on your shard key, then it will directly go to the right shard and fetch your results. That is called targeted operations. So this is how the querying works in sharded database. Think we have come to the end. Any other questions? Oh, just There is no shard within a shard. You can only bring it out and place it as the next adjacent shard. So it's all comes under one linear range of uh, control. That's how it will be. So if you reshard it, it's mostly like you're changing the shard key or the sharding pattern. Maybe you're changing if it's a ranged sharding and you find more data is going into one particular range, then you will be changing the range information on this shard should have only half of this its size. Then in that case, one more shard will be brought up, one more replica set will be brought up, and this from half of the data will be moved to this shard, and then you will have now previously if you had three you will have four shards now, so that's how it will happen. There is no sub sharding as far as I know. Yeah, someone had. Yeah, sure. So when there is a query that the Mongoose is not clear where to send to, so in that case, it will be broadcasted to all the shards. So this happens in scenarios when you are searching for a field which is not the shard key and is not captured in your metadata anywhere and it does not know where to look. Or this could happen in also scenario when the field you are searching is there stored. For example, I told you the example of a pin code we are searching when you are categorized by employee ID. That time it has to search across all the shards. So that time this broadcast operation will happen. It will also happen when you're trying to update all the records, like do some changes in all the records or delete all or something like that. So things like that, if you're doing across all, in that case, your broadcast operations will happen. And your targeted operation happens when you're trying to query by your shard key. So if you have directly know which shard to look into where the data is, Mongoose will directly go to the shard and bring the data back. So this is good. Every shard. Yeah. Any other questions? Mhm. Okay. Right now, I am working in a retail domain where the events are not always of the same structure and the data also keeps growing. So, for example, say customer information. Today, I kind of store four fields and then tomorrow I have more information about the customer. I save it. So, those kind of scenarios are easily dealt with when you have something like a NoSQL database as a document database, and the performance is also like easier on that. I have other people who are worked with MongoDB or working with MongoDB. Maybe they can also share their examples and use cases, how they're using it and how it's useful. Maybe I can pass the mic to.
checklist within a card, but you don't know what type of data you're going to fetch. It can be string, it can be images, it can be bold letters of data, some HTML. You don't really know the structure. Open MongoDB, that's all. That is where you store data as JSON. Or you can also have it as a normalized one, but just in another table. It is not going to pass that sort of join. Join is a major factor between SQL and powerful. As a fan of MongoDB, I would say it's not a big deal for it's about how you query. That is where it is. So because the second option, I can for HTML. If I know that there's a lot of join involved. So instead of the second option, I can go that. Also, SQL is very powerful on joins compared to these things because you know the data. That is the first thing that you will decide, and then only the join comes because you have to normalize and denormalize. You have to think from that perspective. So in that case, the schema is very much defined. Wherein Mongo just not there at the level that you want it. You can get that window, right? The difference.
All right, then any other questions? Each shard can be a replica set as well. So a replica set is the concept where you have the primary and secondary. So each shard can also be a replica set. So you can have multiple nodes and each shard will be having a primary and two replicas. You can configure like that as well. Yes. That's how it will be. Yeah, if no other questions, that was a great audience. Thank you. Thank you, everyone.